Okay, sorry about that. I was updating my VPN software. That was very stupid of me. I wonder if Twitch is gonna cut this into two separate streams now, probably, if I had to guess. Um, let's see. Yeah. Yeah. I'm sorry about that. Okay. Yeah, it's cutting it into two different things. Ah, whatever. So I still haven't published the last two videos that I did at all. It's fine. We'll do that once we're done with this one. Okay. I feel motivated to get these last 4 days sorted, and I think we have a shot at getting all of them. I think we still need to do 18, 19, and 20, and then part of day 17, so it's 4 days. 1 half day, and then 3 full days. The first thing I want to do is take a look. Well, I mean, first of all, close out of more things, because holy cow, I have so many things open. Way too many things open. Okay, you gotta go, and that's it. Wait, I wonder if there's like a better playlist from this artist. Let's see. I really like that. We've been listening to this one a bunch. This one could be nice. Yeah, let's just play this one. How about that? Okay. So the first thing I want to do is take a look at the stats. Which days have people really struggled with? It looks like people have really struggled with day 15 and 17. More than anything else. Part 2, that is. And then day 16, people struggled with part 1. That's very interesting. How did that happen? Wait, how is it possible that... Okay, I'm gonna share my screen. How is it possible that this one has 24,000 people who solved it? This one has 20. And yet, this is a wider graph. Okay, I don't know what I'm talking about. For some reason, more people have attempted day 17 than 16, but way fewer people have completed it. It's so strange, because these two numbers together is 30,100, and then these two is 29,500. That's super strange. Super strange. Alright, I still need to open my chat. So let's just start there. And then put you over here. I got a new wallpaper, by the way. Big fan. I think it's really nice. Yeah, that is interesting. Why have more people attempted day 17, but then so many more people have solved day 16? Very strange. Okay, so it looks like day 18, which was much easier than day 17. Much easier. Like, this is just an insane gap. Like, this one is more than 10 times as difficult. And then, you know, the other 2 days haven't been around as long, so they look pretty normal to me. How about we just get started here on updating my shell? Why not? Okay. Documents, projects, advent of code. I do have this thing open here, and it's supposed to go here, and you're supposed to go there. Okay. And then we just AOCA, and then we just CD to this folder. Well, I guess we're still doing day 17, right? All right. Day 17 was the assembly code puzzle, and we couldn't quite figure this one out yesterday. And by yesterday, I mean 3 days ago. How about... I thought about this a little bit. I think what I want to do here is really print out all the operations in like clear text, which I think should be pretty easy. So, you know, we established last time that the tricky part is that you can't just say, oh, you know, every second number is a command, because sometimes it just jumps to odd offsets, which in turn starts interpreting what used to be the parameter of another operation as the operations going forward. That's pretty tricky. Hence, I think we should start by just printing operations as they happen. So I think, I don't remember how much we changed this input. Ooh, this looks funny. Ooh. Okay, let's not get sidetracked. So let's just go back and download the input again to have a clean input. There we go. And then put this in here. All right. So let's see if part part 1 still works. I think so. All right. So we got test and print. Who gives a damn? I mean, this one we can use once we figured out how this stuff works. Is this printing out the right answer? Yeah, 363. Okay, so the input is correct, part 1 is correct, and now we want to start running this program with a large number and printing out everything that's happening. So let's start by copying this. We already have a clone in here, so we don't make that mistake again. We run every instruction until we're done. And as we're running them, I think we need to... Oh, I didn't save it. I think we need to put in a larger number. So what did this one say? Register A is this number. So I think we established that it has to be a large number. What did we have here before? Whatever this is. Let's try putting in this one. I mean, program has never changed, right? So we can just say, oh, let's just give me program. Which I think is not a list of strings, but a list of integers. So we might want to do str of p for p in program. So let's just say a is equal to this number. And then I think they're at least the same length. So this is a reasonable number to start with. Okay. So what I want to do now is get a clean output, so now it doesn't print anything anymore. And now, whenever anything happens, we want to print the program in plain text. So let's add a new print combo. We return the string of the number. Otherwise, we return the name of the register. And then, yeah, I think that's about right. So let's define a new print run. Print break. And here we print a equals a // And I think we got these format strings in Python where you can just put in print combo, this stuff. I see. Get print combo. Yeah, there we go. And then we do this for all of these. Nope. Remove the slashes. Jump to so now I'm a little confused because I think I should probably print the instruction pointer at every print here. So first of all, they should all be formatted. That goes without saying. And then I think I just put in the instruction pointer, which is I, right? Because this way we have like some information about what this jump is going to do. I don't know, do we want to print the if statement or do we just want to print No, I think this is fine. I think this is fine. Okay. So next up, we got another. Let's get Copilot to do this one. Yeah, I think that's right. Okay. There we go. And then the last one. let's see what we get. Nothing because I'm not executing the print version of the run method. Part. Print run. Thank you. There we go. And then we turn this into frog.txt. Okay. See, this is weird because why would we ever be printing the value of A? That doesn't really make sense. What the heck? Yeah, that's BS. Okay. This one is called printcom. Okay, now we got it. Yeah, that's better. Okay. So how about we start by saying print A equals A, B equals B, and C equals C. And then, you know, just throw in a new line for safe measure. All right, great. This entire time, we're only printing out B, which gets XORed with C right before. And then C is A divided by B. Oh my goodness. I think we should probably turn this printout into a 4. Oops, that's the wrong button. Like, I think these, we should probably say like 4. Because otherwise, sort of strange syntax. All right, okay. So this is the part I'm curious about, because C is A divided by B. Okay. All right. This part kind of sucks because we're looking at the 3 lowest bits of B and C. And B oh, let's pad the friggin' instruction pointer to 2. Add I if there we go. Actually, just pad with the space. That's better. Okay. Yeah, I'm pretty sure the only jumping we're doing is one single loop. So that's pretty straightforward. That's very easy to figure out. So we're making A smaller bit by bit. But actually, just by dividing it by 3? That doesn't really make much sense at all. It doesn't really make much sense at all. Because divided by 3 is not a bit shift or anything. And then C is always the floor of A divided by B. Oh, and B is A modulo 8. Okay. Well, that kind of makes sense because... Yeah, okay. And I don't know if this is really possible because... Like, let's take a look at the loop, right? The loop is literally just these lines here. Which is only 7 instructions. 6 if you remove the print. So B is the lowest 3 bits of A. Then we XOR it with 5, which means we flip the first and last bit. Then we take and we XOR it with 6. Oh my gosh. That's very silly. So we can, okay, let's just make a new document here. We can pretty easily simplify this stuff. Because XOR with 5 and 6, well, 5 and 6 both have 4 sets, so we can remove that one. And then 1 and 2 is just the same as XORing with 3, so that's much easier. Now the real challenge is the C part, right? Because oh my gosh, okay. A divided by B, that's so strange. So B could be any value between 1 and 7. And then we XOR them together. I think once a long time ago I turned off this fan in this phone booth. It's still off. Go off, King. I'm a little confused because I thought... Wait, am I even running this on my real input? Oh, not again, dude. Not fucking again. No, I wasn't running this on my real input. Well, same thing, maybe? Yeah, I removed it. Okay. Because otherwise this wouldn't have made sense. Like, this program is way too complicated to have worked with what we did last time, where we just flip bits manually. Okay. So the part that I'm worried about is that, you know, if we want to define B, B is basically A mod 8 XOR 5 and then XOR So this is the value it has before. So this is C. So we take A divided by this, floor it. So this is C. And then we take this, XOR 3, XOR this, right? We should probably make sure that these are XOR. Yeah, we got B, which is this value. And then we have A equals 4A divided by 3. It's time to ask Copilot, baby. We're running this code in a loop. What value do I have to give A so that it prints out? Let's just start with like the first 3. Work backwards from the last number. For the last iteration, we need A because 1 middle iteration needs A 3 times larger to print 4. I'm not sure if you're right about that, my man. Let's see. Well, that seems wrong. Zero, zero. Okay. Check your work using 27 prints 0, 0. I think walking backwards does kind of make sense. But like, I guess we could just literally run this from all the values from 1 to 7. Let's see. Let's make a new script, call it tmp.py for A in range of 8. And then, you know, the floor thing is instead just this, and this is just this. Do this. Nope. Python. EMP. Division or modulo by 0. Yikes. Yikes, yikes. Okay. Oh, fuck that. What? It happens at 5? I guess. That's so strange. That is so strange. Because, like, how has this never happened before? How have we never gotten 5 in A? Yeah, I mean, I guess that's true. If these bits are 5, then we're fucked. That is so strange, dude. Okay, let's see. I feel like I want to go higher than 8. I feel like this is not an 8 kind of thing. I think this is more of a... Let's just try double. Let's go to 16. And then we do try. And then accept. Exception. Pass. Alright. So we can get to the values... Well, I guess we gotta go higher then. They still have not repeated. That's great. Oh, you know what? We definitely need modulo 8 here. Yeah. Okay. So we should be able to get all the values from 0 to 7. Wait, we don't necessarily need the values from 0 to 7. What we need is these values, which are all the values from 0 to 7, you know? Unique. Well, no, let's sort the lines and then unique the lines. Okay, 1, 2, 3, 4, 5, 6, 7. Great. We need all the values. So we got 1, 2, 3, 4. It's not great that it has to be 25 to be a 4. Does this ever repeat at all? I mean, it has to. There's only 3 bits here. Wait, am I forgetting a modulo 8 somewhere, maybe? In my program? No. Okay. There's 3 mod 8s. There's... Okay. Wait. So this is the right pseudocode. And then this is also the right code. Print this number. And we should be able to see a repeating cycle in here, perhaps. Man, I don't even know. Ugh. This is some pretty tricky shit. How about we run it to 256, and then we put this into a cycle.txt, and then we open it, and then we try finding a damn cycle. 3, 5, 2, 2. Let's just find 2, 2. No, it doesn't repeat. It doesn't fucking repeat. Great. Well, how about this? We go from I think I know how to solve this now. I think I know how to solve this. So we go from 0 to 1,000,000, and then we create a map. We have an A lookup. And then we say A lookup, A is this. And now we need to find in this lookup table the values in this order, and every time we multiply by 3. So we try finding a value that has 0 in it. And then we multiply it by 3. That can't be right, because at the end of it, it has to be 0, because otherwise the loop doesn't break. So we can't just find an arbitrary value that results in the right output. We need to end at 0. Do we even get any zeros? We do. We do get zeros. Oh, man. So what if we run the code with 3 as the number for A? And then 3 times 3 is 9. Wait, okay. So when we ran it with 27, what output did we get? I'm doing okay. I'm struggling with this puzzle that I'm subjecting myself to. We're trying to print out numbers. There's like a piece of code that's written in like this weird language, and we want to put in the right values to get the right numbers out of it. It's very frustrating. I don't know. I don't really know how to approach this one. Like, the weird thing is that if we put in the number 27, we get, what was it, 0, 0? I don't really stream on Twitch. I just do this thing called Advent of Code, which is this little thing that happens once a year. And I'm trying to fill my advent calendar and get all of these stars. And every star you have to like solve a puzzle. But it's like very coding heavy. So there's a lot of coding involved. So I do software development. And this is like a little game you can play where you have to write code to solve it. I'm unfortunately not all that interested in digital art, but I appreciate your reaching out. Okay, wait. Let's try running this with a 27 and see what we get. So how is it possible that 27 prints 0, 0? That doesn't make any damn sense. I appreciate it, Eleanor, but unfortunately I'm not interested at this time. All right, let's see. So if we put in 27, we get 4. But that can't be right, because we just put in 27, and we got 0. So what's up with that? What's up with that? I think my code isn't right. Like, I think I'm not interpreting the program correctly. What am I doing wrong? We have A modulo H XOR 5 XOR 6, which 5 and 6 share 4, so we cancel those out, and then we have a 2 and a 1 left. So that's this value right here. I stand by that. I think that's right. And then we have C, which is the floor of A and B, which is the floor of A divided by A modulo H XOR 5. And then B is B XOR C. Man, what's going on, dude? What the hell is going on? Oh, man. Why do we get 4 and 0? I don't understand how we get 4 and 0. I mean, the only thing I could think of is that I had a brain fart when I did this one. No, it's still 4. So that was perfectly valid. Let's see if the program changes if we put in 27. So if we remove this line and we turn this back into a print run, what do we get? Dude, what? This is the exact same thing. A is 27. We take A modulo 8. We XOR it with 5. Dude, there's something wrong here. There's something very wrong here. Oh. Oh. I'm an idiot. Well, that explains it. So every single division is not by the number, but instead is by the power of 2. You know what? That makes so much sense. There we go. Yeah, that's more like it. Okay. So we cut out... Well, this one is kind of crazy, because, like... I guess we only have one division here. So we do 2 to the power of. So 27 now gives 0. Yes, there we go. Okay, that's much nicer. I still think we kind of got the right approach here. Like, if every time, instead of dividing by 3, we divide by 2 to the power of 3, which is... Oh, that's not right. 2 to the power of 3 is 8. Well, if we divide by 2, we cut out 1 bit. If we divide it by 2 twice. Okay, so we cut out 3 bits, right? So all the values between 0 and 7 let's see. Wait, what's 27? 27 by 3 is 9, by 3 is 3, by 3 is 1. No, 27 by 8 is 3. So we have to take a look. I mean, we're only ever taking a look at the lowest three bits, right? So we gotta find 3 bits. See, this is the weird part though, because like, what if we want to print a 4 and the 4 is not in these? Like a 4 has to be a 14, which is gonna leave a bit the next time around. Okay, okay, I see you, I see you. So let's still do like at least 1000, right? And then we say the lookup. Okay, let's remove some of these. I don't care. Okay. The lookup of A is equal to this. You know what? No. Let's do this. And then we do a.lookup append this, right? And then otherwise we do a.lookup append -1. Yes. Okay. So now we just go through our program, which is in the input backwards. Nums equals this. Oops, that's not quite right. For n in nums -1. I don't know why this has 0. R is empty, or append. A.lookup dot index of n. Is that right? I think the index of an array. Yeah, okay, you got it. And then I believe well, this is not quite right. This is not quite right, because we need to make sure that if we have residue bits from the previous number, like, for example, if we want to get a 4, then it has to be a 14. Which means that, 14 divided by 8 is 1. So the next one has to have the 1-bit set. So we have a residue, which starts at 0. And the A and residue is equal to the residue, I think. Right? I think so. And then the residue is A divided by 8, I think. All right, let's try this one out. So we got this divided by 8 should be 1. Great. And then 3 and 1 should be 1. 2 and 1 is 0. Okay, so I think this is right. So we take Okay, let's see. Python TMP. Mat. See, the fact that this is a 0 is not amazing. I think we need to append n. No, we need to append the index. Jesus, okay. For index, in a lookup, enumerate. That's better, I think. So how about we do a is 0. A times equals 8, a plus equals index. And then we print a, maybe. This right? AOCS, this number? Too low. Well, what do we get if we run it? A equals this one. You just shut up. We get something very different than what we're looking for. It ends in the right digits, 5531, but then it goes off the rails. So why is that? Why is that? How about we start by just, printing the program? I think that's not good. Okay, let's see. Print run. Berg.txt. Does it ever change? I don't think so. So if we take a look at this, yeah, it's just the exact same throughout, right? And if we remove the if, then it's literally the exact same throughout. Okay. Well. How did we mess up? How did we mess up? We messed up somehow. Ugh. We messed up somehow. Ugh. So the 6 we didn't get. Is that right? Well, it's probably because it's probably because if we're taking a look at a number that's larger than 7. Ugh, I don't know, man. I think I'm gonna take a quick break. I'll be right back. I think I'm gonna get a coffee or something. Or some water, perhaps. Ugh. This is a tricky one, man. This is a very, very, very tricky one. I'll be right back. Alrighty. Wait, where did the music go? Oh, there did the music go. Well, we know what the problem is. I just don't know if I know what to do about it. Oh, there goes my camera. That's great. Exactly what we wanted to happen. This maybe? Yeah, that's fine. See, this is exactly the spot where my eye becomes invisible. Okay, wait, as I have this thing happen right now, I want to fix my filter. This has to be, like, fixable, right? Surely this is fixable. Aha! There we go. But the similarity slider is like... I want to change my gamma. How does one fix this? Like if I set this lower, it's fixed, but now I have a green outline. It's bad. It's just very bad. Okay, I'm gonna create a different color green screen. How about we make it this color? Okay. And then I'm going to create a new colored image with converge and make it 720 by 480p. And the color is going to be this one. And we're going to call it cyan.png. And then we go here, go to camera, background, add an image, choose cyan.png, and my eye is still invisible. How's that even possible, dude? Is this... Is it macOS that's messing it up? Because my eye certainly is not cyan. I can promise you that much. It's gotta be macOS, right? I don't think it's the... Wait, what if I just disable it? I guess my eyes are cyan. I'm very good at this whole streaming thing. Okay, so green doesn't work. Cyan doesn't work. How about magenta, maybe? No, my lips are invisible. Ay. I think we could maybe do blue. No. This isn't gonna work. Oh, this is perfect. Just perfect. Whatever, dude. I'm gonna go with this and have a magenta outline, I guess. Nothing we can do about it right now. I think it's better to have an outline than to have my eyes be invisible. I really don't. It's pretty bad. The OBS color green screen filter is pretty bad. I think we can all agree to that. All right. Well, I'm pretty sure I figured out the problem here, right? So the problem is we're trying to go number by number. So we take a look at the low number first. We know which A value produces which output, right? And we're trying to put in the right A value to get the right output. However, there is overlap between the bits that correspond to the previous number and that correspond to this number. For example, if we take a look at the 4, it requires higher bits to be set than the lowest 3 bits. Which, how's that even possible? I think I want to take a look at what the hell is going on here. Like, what does this equation do exactly? I think we should be able to figure this out. All right. New chat. What does this line do exactly? It maps numbers into the range 0 to 7 using bitwise operations. And at most, we would be taking a look at, like, what's the highest this number could be? The highest this number could be is 7. So A divided by 2 to the power of 7 is bit shifting it to be do we just brute force this? Do we just go and brute force the digits? Backwards? I don't think this is solvable through math, dude. I don't think it is. Like, the fact that the bits are affecting each other is just horrible. Like, who designed this puzzle? Jesus Christ. Okay. Ugh. So here's what I'm thinking, all right? Wait, okay. What was I saying? The highest we could have is 7. So 2 to the power of 7 means we XOR it with the bit that's up to 7 up. And that wouldn't matter at all. No, it does matter at all. Okay. So if we subtract 7 bits, that means we are looking at a total of 10 bits. Because if we cut out 7 and we take a look at the top 3, that means we're taking a look at 10 bits at a time. 10 bits. So that's 1024. So here's sort of what I'm thinking in, like, pseudocode, right? So I mean, first of all, let's define a method for this. Calc for A is this, easy peasy. So here's the pseudocode. figure out index I. Start with A0. Go up until... But here's the problem though, because like... Like, what if we keep going up to finally hit this index? But then we mess up the index of the number before. I guess that couldn't happen. Like, if we start with the lowest number and we go up one by one until we hit the index that we're looking for right now, and then we just move on to the next. This will never skip a solution where we could have... Oh my gosh, how do I even explain this? So, let's explain it with... Okay, I should finish my pseudocode and then we can take a look at the next step. Do a plus equals 1 until... wait, let's just put this in a fucking string. Also, Copilot, shut up. Do a plus 1 until calc of a equals nums I. E in reverse. Then we do I minus equals 1. Repeat until yes. I mean, that's correct, but like, also shut the fuck up. Make sure I plus 1 still fits, and then we need to do this for all, because we can cut up to 7. We're looking up to 10 bits into the future. So 10 bits means we need to do this 4 times, right? Because if we look up to 1 bit into the future, then that means we take a look at the next number. Two and 3, we take a look at the next number. 6, the second next number. 9, the third next number. 10, the fourth next number. Okay. So great. Oh man, what the hell? Who designs these? Who designs these? This isn't fun. Is anyone having fun here? I'm not having fun. No, I'm wrong. We're not looking 10 bits into the future, we're looking 7 bits into the future. So we don't have to go all the way to +4, we have to go to +3. Okay. See, like, this is what I'm worried about, because if we go up, let's say we increment the number until we're at like 10, and then we go to the next one, we realize, ooh, it's wrong, and then we have to go up to 11. Is there any chance that any of the numbers below 10 could have fit? I think the answer is no. I think it's no. Maybe, no, I mean, the problem is we take a look at the lower bits first, and then we take a look at the higher bits. And there's a chance that setting the higher bit up by 1 and the lower bits No, I think this is what we need to do. If we figure out step I and we break, then we go back to step I minus 1, and we just keep incrementing the number, and we never put on a bit mask or iterating. Like, we don't just go from 0 to 7, we're going through all the numbers. So then, you know, if we want to go and take a look at the next one, and we're like, oh, this doesn't fit, we can't find anything with higher bits that satisfies these lower indices, then we have truly looked at every single number that can satisfy these lower numbers. So I think that's correct. I think that's right. Oh man, what a puzzle, dude. What a damn puzzle. Why am I so miserable today? Ugh. Nobody knows. Let me just check my emails. No new emails. Okay. I think it's time to implement it, I guess. I just feel like I need to take an ibuprofen or something. I'm not having the best time right now. I think I'm going to do that. I'm going to take an ibuprofen. I think in order to take an ibuprofen, I need to take my keycard with me to go downstairs. I'll be right back. I'll be right back. I need to get my wallet. I'm happy to report they had candy cane downstairs. You're welcome, by the way. Okay. Time to lock in. All right. So we got A parts, which is this. We have probably this. And this is not I, this is I minus 1 len of nums minus I minus 1. Oh, motherfucker. Dude, why is Copilot so ass, dude? It's literally so ass at writing Python code. Like, it always messes up the goddamn indices. I guess maybe it didn't. Like, what is it seeing here? Like, but no, this is wrong because we, motherfucker. No, I know what I'm doing. Python Copilot does not know it. Or not matches lower I, A parts, and A, I think. Wait, no. Okay, none of this makes sense. Current I is equal to 0, while current I less than len of nums. Fuck this, dude. Sure, but let's call it lowercase a. While calc a is not the right number, except this is wrong because it's in fact len of nums minus current I minus 1. Okay, let's open this one a bit. And then if not matches previous I, A, current I, and A parts, we do current I minus equal 1. Zero if I less than len of A parts else A parts current plus 1. There we go. If not matches previous I, current I minus equals 1. Continue. I think that's right. Oh, no, this isn't right because we need to figure out which index it doesn't match. Oh. Okay, no, let's just define this method first. For off in 3, 2, 1. There we go. If A parts not equal to, no, fuck this, dude. If, okay. A is equal to 8 times 8 to the power of off. No, this is also wrong. Because we still need to add the fucking previous parts. Oh my god, dude. For other off in range of off, A plus equals current I minus other off. Well, this is certainly a 1. I guess. Right. Okay. And then I think we do this. Plus equals this. This is wrong, I think. I think this is wrong. Because I think it's the wrong way around. So let's say we're taking a look at 3 before us, right? Then A is times whatever A to the power of 3 is. And then for other off, so we take a look at 1 and 2. We need to take a look at 1 and 2. And for 1, A minus 1, we take A minus 1 times A to the power of off minus other off? I think so. Like, for 0, the offset is A to the power of 3. For 1, it's 2. So 3 minus, yeah, I think this is right. Okay. Well, this happens way sooner. Okay. There we go. So now we got the right A value. And now we say if so the error happens here. If error is not none. So now we say if num not equal to calc, then we return off. I think that's right, but I'm not sure. error minus error, and then 4 underscore in range of error. Like if we're, yeah, I think this is right. Yes. Yes. No. Yes. I don't fucking know, dude. I don't fucking know anymore. No, this is wrong because we need to invert it. Please just revert it for me. Thank you. Ah, this sucks ass, dude. This sucks ass. I think now it's correct, right? Oh my gosh. Okay, so what happens if we run TMP? Is there any runtime errors? Probably not. Yes, there is. Yes, there is. Yes, I do mean nums and not num. Okay, this is taking way too fucking long, so it's not working. Oh! Fuck me, dude. I don't even know anymore. I don't know. I don't know why this is wrong. I do not know. All right. Let's see. Let's see. So how about we run this and then we just get the first 100 lines or something. Broken pipe? That's fine. Index 0, 0. Index 0 is 1? What? Oh. Okay. 0 is 3, 0, 4. Do we get that same value? Well, I don't know. It's hard to find out. Okay. And then we have an error 2 indexes ago. Uh-huh. How about we print the len? Len 0 doesn't really make sense. I think we should do this. Okay, we're up to 20. That's pretty good. That's pretty good. So I think we just removed one faulty A value too many. No, still wrong. Still looping indefinitely. We go all the way back to index 0? With the len? Is this? Well, that doesn't make any sense. So if the error happens at index of 1. Okay, wait. Let's see. Error 2 indexes ago. Index 0 is 3. Then the next value we find is 11. And we say it's 13. You know what? We need to start let's see. Else, it's um 8 parts current R minus I divided by 8, I think, right? Motherfucker. If current I equals len of parts, or rather while greater equals, no, smaller equals pop. Okay, let's see. This might cut it. If current I greater equals len of parts, else a parts. How could this be out of range if we have this fucking check in it? Current I greater equals len of a parts. Motherfucker. I'm not so sure if I'm doing all of this right. What the fuck? How's that possible? Oh my gosh. There we go. So we want to pop if the current index is less than, maybe? No. Yes, I think it's less than. There we go. Okay. Let's see. I mean, we are making progress. I just don't know if we're making progress faster. I don't know, man. Nope. Not it. Yeah. This is not right. I'm trying to solve the first 3 bits first, and then once we solve them, we move on to the next 3 bits. And then if at any point we're making a mistake with the previous 3 bits, we go back and index. However, the mistake might also happen not in the last 3 bits, but in the bits before that, right? That's why we have to backtrack up to 3 times, and that's where this method comes in. But this doesn't work. It doesn't work. I don't think there's like a bug in this logic. I mean, maybe it could be in here. Like, let's say, you know, we're checking 3 bits back. So we have current I minus off, which is the part that we're looking at. But we have to add now all of the previous parts, right? Which are going to be 1 and 2. So we start by saying, oh, you know, give me this value A that we're looking at right now. And then we're trying to multiply this by a to the power of 3 because we're 3 bits ahead of the one that where we are looking for the mistake. And then we also take another this line might be current I minus 1 No, I think it's right. I think it is right. I think it is right. Because I think at the point when we get here, 8 parts is going to have a length that's like current I has not made it into A parts yet. I don't know. This is not the right solution. Okay. Ugh. I don't know. I don't know. I feel like let's try something else. If J in range if lookup J is equal to num of candidates equals candidates append J. Okay. Matches true. If lookup J no. No, we have to do it differently. We can't keep track of all of these. We have to do a search. Oh my gosh. Okay, wait, I need another break. My brain is fried for some reason. I think I know how to get this, but just give me 1 second. I'll be right back. Okay. I think I know exactly how to solve this. Exactly. Find one depth. And then we got the previous steps. And that's it. And then we do for I in range 1000. So I is the len of previous steps. And then we, at the end, just print find one step with no previous steps. If lookup of j not, then we continue. And yeah, here we can just, this is never gonna happen. Okay. And then for other I, other j in enumerate previous steps. Okay, how do we assemble the previous A? Let's see. K is equal to I minus 1, while K is greater than or equal to 0. So we start by saying A is J. Right? I think so. A times equals 8. A plus equals A minus equal 1. And then if calc of A is not equal to if calc A not equal to num A, then break match equals true, match equals false, if not match continue. Okay, otherwise we return J plus find one steps, previous steps with J, maybe? Future is this. If future is not none, return J plus future. Okay, let's see. Don't think it's gonna work, to be frank. Don't think it's gonna work. If I is greater than len of nums, return empty array. What? How's that possible? Oh, it's greater equal, not greater. Okay, these are some numbers. Or A in. -1. Fringe. Okay. Let's see. Ah, motherfucker. Motherfucker. I have a feeling what happened here is exactly what I thought might happen, which is that we're looking at the lowest numbers first. Like, I'm sure we found a possible solution here. Like, sure is a strong word, but I think we have a pretty good chance that we found a possible solution here. I guess I'm wrong. We certainly did not. It's just completely wrong. Like, has nothing in common with what we're going for here. All right. Back to the drawing board. Back to the drawing board. What am I doing wrong? What am I doing? Am I even using lookup? I am. I think that's a good thing because of the math errors. Alrighty. Alrighty. How the heck do we get here, dude? How the heck did we get here? I guess there's a tiny chance we ran through this backwards. I mean, tiny. I don't think that's any better, to be quite honest with you. Yeah, no, it's not. I mean, let's figure it out. We're looking at the last digit first. Which, yeah, that one should be multiplied the least amount. So I think this is in fact correct. Yet. Ugh, this number is just completely wrong. All right, I mean, let's see. Um, Wait, how is it possible that we're like so off? We're so incredibly off. How are we this off? What happens if we remove a number? Three. What the fuck are you talking about? All right. R is now this. Print R. Reversed. Let's see what we get for this number. Just none of this makes any sense. It doesn't end in the right number. How is it possible that we ran this? I'm so confused. Yeah, that is the value. That's the value that we tested with all of these steps. Where if you run calc on it, you get I feel like I'm doing something wrong, but I can't figure out what it is. Like this is A, this is all of them, right? And then K is going to be 0. So this should give 2. Okay, this is what I don't understand, right? How the fuck? Does running this number work fine against nums k, which is just the 0th number, which is this? Because we reversed it. So running this through calc gives 0. However, running this number through main.py gives 0. Okay. So we're onto something here. Oh, it's reversed. It's reversed, but it still doesn't quite work, does it? 0, 3, 5, 5, 6, 4. Here it's at 1. Okay. Okay. How do we fix it being reversed? Well. 0, 3, 5, 5, 6. Yeah, that's where it goes wrong. Okay. Well, let's figure this one out, shall we? How about we just unreverse it? How about that? Okay, now we get 2. We're trying to get 2. So let's see what we get if we put this into here. 2, 4, 1, 5. We're looking for 2, 4, 1, 6. We're getting 2, 4, 1, 5. No, the other way around. We're looking for 2, 1, 4, 1, 5. We're getting 2, 4, 1, 6. Okay, so something is very wrong here, because in theory, the only way we can ever print this number is if they all match. I mean, look, first of all, this is supposed to be 1024. I mean, not that it's going to change anything. Look, I mean, let's make this thing just 2 digits long, right? Or let's say 3. We're looking for 530. then we get 196, which gives 530. Interesting. So something about our approach seems to be working. Is this the same number we had before? Probably yes. Yes. Okay. So something about it is working. Okay. But it breaks at some point. And I don't really understand why. So let's say we're taking a look at you know, all of these previous steps. Clearly it's going to give us the same result. Oh, interesting. Don't think that makes a difference. Don't think that makes a difference. All right. So now give me print calc A is equal to nums k. So we're trying to get to 2415. Okay. So how is it possible that uh, 2415, this number here gives 5, but if we went here it gives 6. Something about this ain't right at all. Okay, wait. Let's get back the number we just had. Let's run this. It gives 2416, while this little guy is saying 2415. So let's see if something about the program changed here. Probably not, but maybe. Okay. Let's see. No, definitely did not change. So why the heck? I mean, we can do the fucking math again, but 2 to the power of what? Jesus Christ. Oh. Nah, that sucks. Okay. Scientific thing. 2 to the power of 3 is still fucking 8. So A divided by 8. Man, this is so confusing. I'm so confused. I'm so confused. How about at every point when we print the 8? How about, oh gosh. I think that's it. Okay. How about at every point when we were to print another number? We print a. So do these line up with these is the question. They do. Oh, not quite. What the hell? How does it differ? It's off by 12? Yeah, dude, day 17 fucking sucks, man. I'm having such a bad time over here. This is like my 5th different approach. I've tried so many things. I am doing recursive stuff. This is my code right here. But for some reason, I'm off by 12. That sounds so stupid to say. So basically, where I'm at is that I'm building the steps, the iteration steps over time. So I'm building the number A by adding a bunch of numbers, multiplying by 8, add a number, multiply by 8, add a number, multiply by 8. So for every step, I'm trying to find the right number. And in the recursion step, it's checking. I mean, technically, I don't really need to do this. Yeah, I guess you're right. I'm doing the 10-bit window, but with the recursive checking, I don't need to worry about it. The thing is, like, you know, I'm pre-calculating some of these numbers, but I don't think I need that. I think what I can just do is like calc j and then remove this step. And then this is also like, this one could just be like a very high number. Doesn't really make a difference. I'm never exhausting these options. This is just like an upper bound for how large every step could get. No, I also don't think that would cause issues. So here's where I'm at right now. Currently, I am going... I've hard-coded one single recursive step. So assuming we found all of these numbers, and we're trying to find the next one. It's going through all the possible values that could be the next step, and it's checking that the calculation matches. And then if it does, it goes to the previous index, takes a times 8, adds the previous steps, and checks if we calculate that number, we still get the right previous step. It shouldn't only be 0 to 7, because the calculation takes into account not just I guess maybe that's the problem, huh? You know what? I think I figured it out, because I think I do have to add the portion, like here, I need to do j plus equals previous steps, blah, 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 blah. Like, I need to, yeah, that's exactly right. I think I just figured it out. Okay. Wait, let's go back. Let's do this. Let's see what we get to here. That's the number we tried before, right? I think I figured it out. There's spillover from the previous numbers into the current one because the numbers get larger than 8. So we need to make sure that we do for previous index, previous value, in enumerate previous steps. J plus, I knew I had to do this at some point, but I must have forgotten it. Previous value divided by a to the power of previous index. Right? Right. Maybe. I don't know. I don't think it's a plus equals. I think it's a bitwise OR. Because if the previous chunk that we're looking at has a value that's higher than 7, then we need to make sure that we're setting the bits to the previous value that we found. I don't know, maybe that's right. Int and float. Yeah, well, it's supposed to be an integer division. Okay, so now we can't find any result anymore. Great. Great. Oh, man. How about we do something different? How about we do j equals j modulo h. Also not finding anything. That kind of sucks. I think that's wrong. I think I think I'm going through the index the wrong way. Like, I think it's not times this. I think we would have to reverse previous steps. No, we're still good. Yeah, I'm I'm hella confused about the approach as well. So I can explain my approach. What I'm thinking is I take a look at one iteration of my program at a time. So I've reverse engineered the program. I figured out that there's this, recursive step. So I'm trying to find a value that A has at this step. And I'm trying to increment A for this step and then check if the previous steps still work. So I'm going through all the possible values that A could have at this point, which is in range of 1024, because I've determined that this method looks at most at 7 bits in the future. Yes, I'm very aware. I know that I'm bit shifting to the right here. I know that. Yeah. I guess what I'm struggling with is I'm going through the input one number at a time. I'm trying to find the right section of A that gives me this value. The problem is that I have to look at more bits than the current 3 because we're bit shifting by up to 7 bits. So I'm taking a look at 3 plus 7 bits. So that's why for every single index, I'm going through 0 to 1024, which is 10 bits. And then I'm checking if this section produces the right value, if it gets printed. So I'm printing all of the values. And then we need to make sure that the value we just found doesn't break any of the previous conditions. And that's why I'm going through the previous numbers and checking if we're still right. So here we're constructing A for the previous indices. But I don't think that is gonna work. I think I need to go through the numbers 1 through 1024. Like, you understand my problem, right? Like, I'm trying to, here I'm looking backwards and checking if the previous values are still right. And then here I'm trying to satisfy that the higher bits that we've set for the previous steps are still set. I think this one is wrong. I think this is not right. Okay, first of all, this is, I think, previous index plus 1. So if j divided by this is not equal to previous value, then we break. And then we have a match equals true, match false, if not match, continue. All right, that's better. So here we're checking the previous. Do I know the right answer? Well, I mean, I know the right answer. I know that it's supposed to print this value in the end. I am kind of pretty almost close, but not quite. Yeah, I mean, you know, I'm pretty sure I'll find my number soon. Okay, so again, there's like 3 different steps to this, right? Where for every section, we're going through the numbers of 1 through 1000. We make sure that all of the previous values are satisfied. Like, let's say we found that the last step should be, you know, 80. Then we need to make sure that the value that we're looking at in the next step, if we divide it by 8, produces this modulo 8, maybe? Oh, wait, give me 1 second. I think we do previous value minus previous value modulo 8. No, that's still not right. So the j value divided by 8 to the power of previous index plus 1. Because we're going through the previous backwards. Has to be the upper bits of the previous value. I think it's not divided by, I think it's times. Ref step and yes, yes it is. Yeah. Wait, I'm like 99% sure that it's in these 4 lines right here. So I'm trying to make sure that wait, I think I got it. I think I need to do this. Yeah. Oh, man. Oh. Not equal to j modulo. No, no, no. This is not right. This is not right. I'm doing something wrong in like checking if the previous step is still satisfied. Man, this song kind of sucks, doesn't it? Okay. Um, so we need to make sure that the upper bits. I think it's just J mod 8, right? I think that's right. So for the current value, for the current step, we take a look at 3 bits, and we need to make sure that the previous value divided by this value, and then also mod 8. I think that's maybe right. Previous value divided by 8 to the power of stops when the current step is incorrect, which recursively backtracks until something correct all the way through is correct. Yeah, I mean, look, the problem that I'm running into is that for every single printed number, the value that's in A, we're not just taking a look at the lowest 3 bits, we're taking a look at the lowest 10 bits, which overlaps with the next step, right? So we need to make sure that whenever we're finding a number for one step, the last 3 steps still work. So I think I'm definitely taking a look at too many values. So how about we just take a look at the last 3, which I think is -3 colon, right? So for the last 3 steps, which is where the bits overlap. No, that's not quite right. Because then we would be looking at 12 bits, but we only need to be looking at 10 bits. So how about we just... I just really like this playlist. Okay, wait. We're looking at 10 bits at a time. Taking a look at 10 bits at a time. We need to check. I don't know, man. I feel like before I do any more coding, I need to think this through a bit more. Like, how do we solve 10 bits at a time? and make sure that the bits we found are valid. Like, we start by setting the highest 3 bits. And then we it's a tough one. I don't know. I'm really struggling here. So, what am I doing wrong right now? What I'm doing right now is try to go through all the numbers that are in 10 bits. Try to freeze them for the current iteration step. No, I don't think that works. I don't think that works. What I could try is go through the number bit by bit. Flip a bit. That also doesn't really make sense. Yeah, I don't know. I'm trying to go through it 10 bits at a time I'm trying to go through it 3 bits at a time, but freezing more than 3 bits, like freezing bits in the future. It all went so well on day 15, and now I'm here completely struggling. I'm gonna need to get my laptop charger because my laptop is at 5% of battery. So I think I'm gonna do that, and then I'll be back in just 1 sec. It's a tough one. It's a tough one. Alright, I'm gonna be doing some thinking in the next 5 minutes as I'm getting my charger. I'll be right back. Okay. This truly is not a great playlist. Let's see, what else do we got? Let's try this one. Why not? Okay. All right. Oh, man. It's tough. Like you're trying to solve the lowest 3 bits. Like, I think I need to change my iteration to work on bits and not on numbers. I think that's going to make it easier. I also desperately need to check a message. Oh. Okay. So the lowest we're taking a look at 10 bits at a time, and then we subtract 3, and 7 bits are already accounted for, right? So no, this sucks, because then we're gonna have really high numbers if we start freezing the low bits. I think we should go in reverse and make sure that we print out. I think going in reverse makes so much more sense. Like, we start at 0, we go all the way up to 1024. We take the highest 7 bits, we take them over into the next number. as the high bits, and then we iterate on the low bits. And yes, I think that's going to be it. I think that's the winner here. So we start by going through 0 to 1 to 1024. Okay. Okay. Got that taken care of. Now I think it's time to go for it. So this fucking day is the end of me. I swear. Okay, let's take a breather, drink some water. Drink some coffee. I think it makes so much more sense to go through it not in reverse. I don't know why I went through it in reverse. I think that was something ChatGPT told me to do. But I think that's a mistake. So how do we do this? For the next step, what we do is take the previous number, multiply it by 8, bitmask OR with 10 times f, which is 1023. And then we add to that number the numbers of 0 to 7. And hope we find a match. And if we don't, we have to go back up to the previous one. I think that's right. I think it's that simple. Okay. I think it's that simple. Okay, let's just code this. This shouldn't take more than like 5 minutes. And then I think we're finally done with this day. How long have I been doing this? 2 hours? 3 hours? Jesus Christ. Man, this day was the actual death of me. Okay. Let me make sure I've closed out of everything else. I did. And then I shall go here. Where did you come from? Okay. And then the chat is going here. Great. All right. Here's what's going to happen. 4. You can see my screen, right? Yes. Okay. J in range 2 to the power of bits. Is that right? I think that's right. I think 2 to the power of 3 is 8. And then 2 to the power of 10 is 1024. If calc of J plus rev ref is equal to ref times H bit mask and 1023. I think that's right. For J in range, if J plus pref equals to if find number I plus 1 next future is non-continue. Future is this. I guess we do have to add pref to it, don't we? We carry the pref. And bits is 10 at the start. Okay. I think we return future plus J times 2 to the power of I, perhaps. No, that's not right. I think it's 2 to the power of this minus I minus 1. Python temp. What? Oh, it's TMP. None. Great. Nothing was found. Problem solved. Fuck off. Okay, great. This is amazing. Oh, man. Let's see. Let's see. I think this feels right to me. The first number I minus, okay, len minus, okay. returning none too often. Maybe this isn't supposed to be a 3. Maybe this is supposed to be. Okay. Certainly too small of a number. No, it has to be 3 because we're cutting away those bits. So it couldn't be. We can't change them anymore because we already froze them. Let's see. Let's see. Okay. We're trying to find the ith number. First one is 0. We're trying to find a 2. Or j in 0 to 1024 if calc of you know what? How about this? There we go. What I'm so confused about is why all of a sudden we're no longer getting divided by null. Oh, that's probably why. Okay. How about we just call pref a, and then we do times 8. That's a little simpler, isn't it? Thought that was it. That's a little sad. Let's see. I wish I knew. Maybe we should call it crash. That makes it a little bit easier. If I equal to len of nums, print I j. No, like actually I. Yeah. We are getting pretty far into this one, up to 10. How many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 10. 1, 2, 3, 4, 5, 15. The maximum we got to is 10. And then after 10, it can't get it to work anymore. It always stops at 10. We aren't getting to 11. Okay. Something about this isn't right. I don't think we can do 8 times 8. Maybe we can. No, I don't think this is right. I think we need to do something different here. Like the largest number. I don't know, man. I'm so damn lost. Let's just try going through this way and just see what we get to. We do get to something. I don't know, man. This feels a little high. This feels a little high. Let's see. Not even close. Not even close. Okay, well, I need to rethink this. I need a break. I have other things to do today. I didn't think this was going to take 4 hours to just do the first half of the days that I was trying to do. Not great. Not great. I think this is it for today. I have too many other things to do. I can't sit here all day trying this. I'll probably be able to figure out what I did wrong if I think about it some more. Like, it's something about, like, you know, multiplying by 8. I'm just taking a look at the wrong bits, that's for sure. Like, something about this just isn't right. Alright, well, that's it for now. I can't stop thinking about it. Anyway, I need a break. I'm gonna do all of Evan of Code by the 25th, but not today. I will be back, I promise. We will solve this, and I will not look at anybody else's solutions. And I think I'm really close. I really think I am. Alright. Yeah, dude, day 17. It's probably not the hardest Advent of Code I've ever done, but it's up there. Like, it is very difficult. I think I also got pretty unlucky, but with, like, not choosing the right approach a couple of times. But I've changed approaches like 4 times already, and I'm still not there. I don't remember day 11, but hang in there, you know? If I can solve day 17, so can you. And I think I can, just not today. It's been a long day and I haven't gotten enough work done. So I'll be back, I promise. Maybe 8 Coolga, you can turn on the notification when I go live, and then I'll solve the rest of it next time. All right. Peace. Bye-bye.